as I said was the type of reactions that are forced to occur. They are what they are called non-spontaneous. Why those that occurs what on their own, they are called spontaneous reactions. And for the spontaneity of the reactions, what are the conditions that have to occur is delta G must be negative for the spontaneity of the reactions. Why for the not spontaneity of the reactions, what are the conditions that have to occur is that delta G must be positive. And if delta T is positive, or it means what delta H is also positive. But we are not into that. So I just wanted to know that what are the formulas that we have to know under the electrolysis. Now on the first one is what is the first one is M equal to ZIT. M equal to ZIT. The first formula to know under the electrolysis is equal to what? M equal to ZIT. And where do we derive this formula from? Now, where do we derive this formula from? Now, this formula was actually derived from what? From the Faraday's first law of electrolysis. Now, the Faraday's first law of electrolysis states that what? The mass of the element deposited or discharged during the electrolysis is directly proportional to the quantity of electricity that passed through them. That is, M was from M equal to M is the mass of the element is that deposited is directly proportional to the quantity of electricity that passed through them, right? Now, don't forget that anytime you are removing sign of proportionality, we usually introduce a constant, right? But this time around, the constant we are introducing is constant Z. Now, if I remove this sign now, I'm going to have M equal to is ZQ. But don't forget that the quantity of electricity is equal to current multiplied by time. Is that okay? So our Q is equal to what? Q is equal to what? Q is equal to current Current multiplied by what? Multiplied by time. Do you get it now? So, and if current is equal to, if quantity of electricity is equal to IT, that means I can go back to this to this expression, and I have I have M equal to Z. Instead of putting Q, what we put is IT. Now the first formula to know under this electrolysis is the M equal to ZIT. I hope you are getting that. So that's the first formula to know under it. Now the second one is the second formula to know is and before we actually move, before we actually continue, now what is that Z? What is that Z? Now, what's the Z? This is called electrochemical equivalence. It is called electrochemical equivalent. Now, but do you know that this electrochemical equivalent also has a formula, but they will not tell you. Do you get it now? I don't know, maybe you have actually read it before, but it is very, very rare to find these formulas in your textbook. Now, the electrochemical equivalent Z is equal to now the molecular mass relative molecular mass divided by charge of elements multiplied by Faraday constant. You can see that I actually said this formula is very, very rare. Do you get it now? So some of you might know it, while some might not actually know the formula. So the formula is equal to this electrochemical equivalent Z is equal to It's equal to the relative molecular mass divided by the charge of the element. That is the charge possessed by the element. So if you are talking about aluminium now, so the charge possessed by aluminium is plus 3. If you are talking about sodium, is plus 1. Calcium is plus 2. Oxygen. If I ask you what's for oxygen, you tell me -2. No, because there are some what? There are some reactions. For example, now anodic half equation for oxygen. We have what? We have 4 OH minus to give what? To give 2H2O, right? Plus oxygen gas plus 4E minus. That is 4 electron is what is actually required to what? To actually deposit oxygen. Definitely the charge of oxygen here will be 4. Do you get it now? So this charge means what? The charge carried by what? By the elements. Sodium is +1, calcium is +2, aluminum is what? Is +3. Do you get it now? Zinc +2, copper 2 plus. Is that okay now? So those are the charges. That means their relative molecular mass divided by the charge carried by the element multiplied by Faraday constant. And do not forget that 1 Faraday constant is equivalent to what? To 96,500 coulomb. Hope you are getting that. So the first formula to know is what? Is the mass of the element is equal to the electrochemical equivalent multiplied by current times time. Do you get it now? And what is now the formula for that electrochemical equivalent? So the formula is what? The relative molecular mass divided by what? The charge of the element multiplied by the what? The Faraday constant. Hope you are getting that. Now, after knowing the first one, so the second formula to know is Q equal to NCF. This formula is very, very important. Q is equal to what? NCF. Again, what I call the Q equal to what? Q equal to NCF. Now, where my Q is the quantity of electricity, my N is what? The number of moles. My C here is what? The charge carried by the element, and my F is what? Is the Faraday constant. But do you know that from this expression or from this equation, I can actually make it like this: N equal to what? Q divided by what? Divided by C what? CF. I can actually make the what? The equation to be like this. So if I divide both sides by what? By CF, I'll be having what? The number of mole equal to what? The quantity of electricity divided by what? Divided by charge divided by Faraday constant. Do you get it now? But do not forget that this number of mole has different formulas. So depending on the parameters you are working with, do you get it now? So I can change this number of mole to different formula. I know I have different formula for number of moles. That means if, and do not forget that your Q is equal to what? Equal to IT. That means this formula can also change to what? N equal to what? N equal to IT over CF. Hope you are getting that. The first one is what? N equal to ZIT. Very important. And I told you that what? This Z is called electrochemical equivalent. Sometimes JAM will give you as ECE. Do you get it now? So JAM will give you this constant as what? As ECE. Now what's the full meaning of ECE? Electrochemical equivalent. You can see that sometimes they give you as Z. Sometimes they give you as what? As ECE. Sometimes they can even give you as what? As capital E, like this. Hope you are getting that. So JAM can give you as either capital Z or what? Or capital E or ECE. So where ECE means what? Electrochemical equivalent. Hope you are getting that. Now, so the second one is what? Q equal to what? NCF. What is my Q? Q is called what? The quantity of electricity. Now, and this N is what? Is the number of moles. My C is what? The charge carried by the elements that involve that electrolysis process. And my what? My F is what? In the Faraday what? Faraday constant. So now, I now told you that what? This formula can actually change to what? To N equal to what? Q over CV. Do you get it now? So, and I already know my what? My Q. That's the quantity of electricity, which is equal to what? Current times what? Times time. Divided by what? Divided by what? The charge raised by the element multiplied by the Faraday constant. But don't forget that 1 Faraday constant is what? Is equivalent to what? To 96,500 coulomb. I hope you are getting that. Now, so do not forget that I have different formula for number of moles, right? Now, I have different formula for number of moles. Now, my number of mole can be what? Number of mole can be, so number of mole is equal to what? Is equal to mass over molar mass. No, if you don't know stoichiometry now, This aspect will be very, very what? Very, very difficult. That's why you have to know what? You have to know different topic. You have to know a topic. There are some topic that you must know before you are moving to another topic. For example, now stoichiometry is very, very important. You have to know it. I think I've actually dropped videos on stoichiometry. So there are some what? There are some aspects in stoichiometry that you have to know before moving to other subject, I mean other topics. Now, so the number of mole was mass over molar mass. Now that means if my number of mole equal to mass over molar mass, do not forget that N equal to IT over CF. That means anywhere I see number of mole, I can actually substitute the value to be mass over molar mass. That means this expression or this equation will now become what? Mass will become mass over molar mass equal to what? Current times time divided by what? Divided by C what? CF. Now it means that what? Anytime they give us the mass and the molar mass of the element, so they are now asking you to calculate either the current or time. So anytime they relate mass, molar mass, current, time, and the Faraday constant. So the formula to use is what? Is the mass over molar mass is equal to what? Current times time divided by what? Divided by what? The charge of the element multiplied by what? Multiplied by the Faraday constant. I hope you are getting that. So that's the second what? The second formula. Now, if my number of mole is now given as another thing, no, this one is mass over molar mass. So if my number of mole is what? Is given as what? Is given as now N equal to, no, there's another formula, concentration times volume over 1000. Now, when can I use 1000? Is that when your volume is given in centimeter cube, so you have to convert it to dm cube. But assuming they give you your volume in dm cube now, so you have to leave it in as N equal to CV. So you not divide it by 1000. Why? Because we are working with volume. The volume given to you at that time is in dm cube. But if it's centimeter cube, so you have to divide it by 1000. So assuming that they are talking about the concentration and the volume, so your formula will not change to what? CV over 1000 equal to IT over what? Over CF. So this is what I'm telling you now. So you have to know the formula for the number of moles, or the formula for the number of moles, and if you know them, now we now be substituting it to the formula N equal to what? IT over CF. So I've already told you that it can be mass over molar mass equal to what? Current times time over CF. If the number of mole is given as mass over molar mass, but if it's given as concentration times volume over 1000, so it should be CV over 1000 equal to what? Current times time over the charge of the element multiplied by the Faraday constant. Now, if your number of mole is given as what? No, number of mole can be equal to number of atoms divided by Avogadro constant. Do not forget that you also have another formula like this, Abi. That is what? The number of mole is equal to what? Number of atoms divided by the what? Divided by the Avogadro constant. So now, number of mole what? Number of atoms over Avogadro constant. So now, if your number of mole is given as this, right? So that means this formula can now change to what? To number of atoms over what? Over 6.02 times 10 raised to power 23 equal to IT over CF. I hope you are getting that. So different formula. So just know all your formula for the number of mole. The first one is what? Mass over molar mass can be equal to what? Current times time over the charge of the element multiplied by the Faraday constant. That's the first one. Second one is what? Is the concentration times volume over 1000 equal to current times time divided by what? Divided by CF. Now the next one can be what? Can be number of atoms over Avogadro constant. That's 6.02 times 10 to the power 23 equal to what? Current, that's our I, times time over, this is not concentration though. This was the charge carried by the element multiplied by the Faraday constant. So the next one can also be what? Can be if they give you the number of mole as volume of gas over volume at STP. You can see. So the number of mole can be what? Can be volume of the gas over what? Over volume at STP. Now the volume at STP is what? Is 22.4. Sometimes we call it what? We call it gas molar volume. What do I call it? Gas molar volume. Anytime you hear what? Anytime you hear gas molar volume, they are what? They are talking about what? They are talking about what? They are talking about the what? The volume of the gas at STP. Now if the gas molar volume is given as 20.4, do not forget that. Now if do not forget that what? 20.4 is in DMQ. This one is in DMQ. So that means my formula can also change what? Or number of mole equal to volume over what? 22400 centimeter cube. That means if your volume is given in cm cube, if your volume is given in cm cube, we are using this one. Number of mole equal to what? Volume over what? Over 22,400 cm cube. But if it's in dm cube, the number of mole equal to what? The volume over 20.4 dm cube, right? Now, so that means if the formula is like this now, so my equation can tend to what? Can tend to now number that is volume over 22.4 equal to what? IT over CF. Or if they're giving you what in centimeter cube, it will be volume over what? 22400 abi equal to what? IT over what? Over CF. Now what do I call my volume for you? What do I call V for you? That's volume. So what do I call I for you? That's current in ampere. So what do I call T for you? That's time, either in seconds, hours, or minutes, depending on what the question wants you to express it as. So and what do I call C for you? The charge carried by the element. So what do I call F for you? The Faraday constant. Now, so the last one that they can give you is what? When they express the number of mole as this. Don't forget that number of mole equal to what? PV over RT. Now, do not forget that from ideal gas equation, PV equal to nRT, right? From ideal gas equation, PV equal to nRT. Now, this number of mole, this one is what? Is pressure, right? In ATM. Now, volume in dm3. This one is called gas constant. What I call is gas constant. So which has the value of 0.0821. Do you get it now? So and this one is absolute temperature. That is temperature in Kelvin. So you have to convert your temperature to Kelvin. So that means if your number of mole is what is expressed in this way, now the formula will now change to what? PV over RT equal to IT over CF. You can see I use capital T here, I use small t here. Capital T is the temperature, while small t is what? Is time. You can see that temperature, this one is what? This one is time. That is pressure, volume. This one is what? A gas constant. This one is what? Absolute temperature in Kelvin scale. This one is what? Current in ampere. This one is what? Time in seconds or minutes or hours. Divided by what? Divided by the charge of the element multiplied by what? Multiplied by what? The Faraday constant. So these are the formula that you have to know about this particular topic under the calculation aspect. So now, after knowing the first one is what? M equal to what? ZIT. Second one is what? Q equal to NCF. So we actually derive all these formulas from from the second one, which is called what? Q equal to what? NCF. I hope you are getting that. Now the third one is what? Is number 3. Now it is very, very important. It's number 3. So number 3. Now number 3. Now this number 3 is actually what? It's actually from what? From the Faraday second law of electrolysis. Now the Faraday second law of electrolysis state that what? Say that if the same current passes through different electrolytes, like we have the same current that is now, so that the same current now pass through different electrolytes. So it was said that the numbers of the moles of the element discharged during the process is inversely proportional to the charge carried by the element. That is what number of mole is inversely proportional to the charge of the elements. So that means from this statement, if I actually remove this sign, don't forget that that anytime you are removing sign of proportionality, what's happening is what you are going to remove that sign and insert your constants. Now this time around, if I remove this thing, I will have what n equal to what k over c. I've already removed my this constant, right? I mean my this sign. So if I now cross multiply now, I'll be having k equal to nc. Do you get it now? So k equal to what? K equal to what? Nc. And what's my n? Number of mole. What's my c? The charge of the element deposited. So that means from this expression now, I can have what? I can have n1 c1 equal to n2 c2. Do not forget that it's like gas law. No, under gas law we have what? We have Boyle's law. As we have P1 V1 equal to P2 V2, we also have what? N1 C1 equal to N2 C2. Now, where do we derive this formula from? It's what? Via this second law of electrolysis. We say that what? The numbers of the moles of the elements, like when the same current pass through different electrolytes, the numbers of the moles of the element discharged during the process is inversely proportional to the charge carried by the elements. Hope you are getting that. So which is what? N1 C1 equal to N2 C2. Now this N1 is the first element, N2 is what? The second element. They are different, they are not the same. Hope you are getting that. So now that means from this equation now, which is N1 C1 equal to N2 C2. Do not forget that my number of mole can be what? Can be mass over molar mass. That means it can be M1 C1 over MM1 equal to M2 C2 over MM2. I hope we are getting this. Now do not forget that number of mole is N, and number of mole is what? Is mass over molar mass, right? That means when you are talking about N1 can be expressed as M1 over MM1. N2 can be expressed as what? As M2 over MM2. So this expression now, this equation is the same thing as M1 C1 over MM1 equal to what? M2 C2 over MM2. Hope you are getting that. Now, for example, now in equation now, they are talking about what? Silver and zinc. What do I call it? They are talking about what? Silver and zinc. Now that means silver will be first element, while zinc will be second element. That means for the C1, it will be +1 because silver has +1 at the charge. Now zinc will be second element. It has what? It has +2. So the C2 will be +2, right? And they give you the molar mass of the two elements. So silver has one molar mass of 108, while zinc is what? Is 65. Do you get it now? So all these things were very, very important. First one, M equal to what? ZIT. Second one is what? Q equal to NCF. And I actually we derive different formulas under this number 2. And number 3 is what? Is from the second law of electrolysis. That is N1 C1 equal to N2 C2. My N1 is what? Is mass over molar mass, right? That means N1 can be M1 over MM1 times C1 equal to what? M2 over MM2 times what? Times C2. Hope you are getting that. Now, so the last one that you now have to know is what? Is the cost of electricity. Now, cost of electricity. JAMB usually ask that question. Cost of electricity required to deposit elements. You see, this formula, I swear to God, it's not in your textbook, but I will give you the one that you will know. That if you just know them, you are fine. All this formula I give you now. So now just write it down, go and memorize them, then go to your past question, go and solve question under it. Now the last one under the formula under electrolysis is what? Is cost of electricity. And I actually give my students this formula. That is M1 C1 over MM1 multiplied by MM2 over M2 C2 equal to capital N1 over capital N2. You see, just go and know this formula. Anytime they ask you to calculate any cost of electricity. So the formula used is what? Is M1C1 over MM1 times what? Times MM2 divided by M2C2 equal to capital N1 over capital N2. Now let me analyze them for you. M1 is what? The mass of the first element. C1 is what? The charge of the first element. MM1 means what? The molar mass of the first element. MM2 means what? Molar mass of the second element. M2 means what? Mass of the second element. C2 means what? The charge possessed by the second element. And the capital N1 means what? The cost of electricity required to deposit first element. And it is in naira. It is in naira. Do you get it now? So the capital N1 means what? The cost of electricity required to deposit what? The first element. Why capital N2 means what? The cost of electricity required to deposit second element. So JAMB can either ask you either capital N1 or capital N2, but note they will give you one capital N1. So it might be N1, it might be N2. Hope you are getting that. Do you get it now? So capital N1 means what? The cost of electricity required to deposit first element. While capital N2 means what? Cost of electricity required to deposit what? Element 2. Now again, what are the formula that we need to know under the electrolysis? Now there are how many? There are 4. There are how many? There are 4 or 5. Now number 1, I said well, M equal to ZIT, right? Number 2 is what? Q equal to NCF. Abi now. Number 3 is what? N1C1 equal to N2C2. Number 4 is what? M1C1 over MM1 times MM2 over M2 C2 equal to capital N1 over capital N2. So the one that I'm supposed to add is what? Number 5 equal to what? Is Z equal to relative molecular mass over CF. Hope you are getting that. So these are the formula that you have to know under electrolysis. Number 1, M equal to ZIT. Number 2, Q equal to NCF. Number 3, N1C1 equal to N2C2. Number 4, M1C1 over MM1 times MM2 over M2C2 equal to capital N1 over capital N2. And the last one is what? Z equal to relative molecular mass over charge of the element multiplied by the Faraday constant. Now, so know this formula and go and blast your what? Go and blast your Utme. Hope you are getting that. So note all this formula and go and blast your what? Go and blast your Utme. So thank you. Now, so just send this video to your friend that you know that they want to write what they want to write 2026 Utme examination. So very what